So we're going to do a bit of a question and answer podcast today with our good friend, Dr. Eagle, Cameron Munro, the building scientist, rocket scientist, and Brad from Sanford Buildco plus Hamish. So these are questions we actually put on social media recently and just got people to ask us anything essentially, and we thought we'd have a bit of fun with it and see what people come out with. But I've got 5 here that are really appealing, with one of them being asked multiple times. And it's something I think we've actually spoken about before, Cam. The question I have here is, what will happen if I make a house so airtight but have no mechanical ventilation?
Well, it'll be pretty energy efficient. You're not going to get the air loss. The problem is going to come down to air quality. It will need to be opening those windows very regularly, and then you're relying on those windows to actually provide adequate ventilation, which you can't. This is the whole point of HRV, that it's about predictability and control. So you're utterly dependent on the weather outside to provide adequate air movement through the building. And so the energy benefit you had from going airtight is now lost. The final risk is one of moisture, because you've got no predictable way of removing the moisture from the space that you do have with HRV. It's not a good place to be.
Have you guys had clients say, oh, we want to build airtight, no mechanical ventilation?
Not airtight, but want to mystically pluck a number, like I want to build 3.5 ACH and not worry about mechanical ventilation.
You're builders, you can do that, can't you?
Yeah. But I think this is the issue when we talk about airtightness, like, and the magical number. Like, you've said it before, Cam, that like every house needs some form of mechanical ventilation. And I think the issue is in our industry, when we talk mechanical ventilation, it's HRV. We've got exhaust fans.
And rentals.
Yeah. So like, where does that...
And fans.
So you do need some mechanical ventilation to some extent.
Yeah, I keep saying this. In my view, the question of mechanical ventilation is utterly independent of airtightness.
Yeah.
Every home needs mechanical ventilation, just like every home needs toilets and a kitchen sink and everything else. It should just be not even a question.
And I think you've even talked about, like, the important thing is the ventilation part of it. Like,
Not the heat recovery.
Not the heat recovery. It's just the ventilation.
Absolutely. And so the usual pushback is, oh yeah, but a HRV, heat recovery ventilation, is going to cost me north of 20 grand. I don't have that money. I don't want to do that. Okay. So the way to provide that ventilation is an extract only system with a makeup. And so it can be as simple as the $20 bathroom extract fan. You leave it on 24/7, and then you have a window open at the other end of the house. So you continually draw air through the house.
But intuitively, that will cause a problem to your heating and cooling.
A massive problem, unless you happen to live in a benign climate where it's 23 degrees outside all year round.
So if we don't have mechanical ventilation, what will you sort of feel and see? Have you guys experienced anything?
I mean, personally, no. And I think luckily, in my professional experience in building higher performing homes that are also airtight, that we've always had some kind of dedicated ventilation system. Now, there has been some projects where early on when we were quoting and I guess getting into this high performance space, sure, we were trying to put in some of the passive house principles, and ventilation always comes up as, oh, well, why don't we just get rid of that? There's $25,000. And luckily, I have never been in a situation where that has happened because the project's just fallen over. So personally, thankfully, I've never been in a situation where we've got an airtight building and there's been no ventilation.
And what I'm interested here in, because you builder, building scientists, how you both have different conversations with clients about it, because I feel like the conversation you'd have with a client about mechanical ventilation is different how you would have the conversation, but trying to get to the same point.
Well, I'm not trying to sell anyone on it. I'm just saying, if I'm building your house, this is how I'm doing it.
So how would you then go, how about, let's then go back a step. If you're a young builder and I want to build for the first time and I understand the importance about it, how would you talk to the client about it? Other than being like, no, it's going in.
I just think if you're a young builder, you should be wanting to eliminate as much risk on your part as possible. And that's how you eliminate the risk. I still to this day can't figure out a recipe to build to a certain level of air tightness. And even if you periodically tested your build as you were doing it, And then you know, whatever, especially with modern architecture, everything's square set. If you're doing a good job, you're corking everywhere. You're going to be relatively airtight without really giving it a full send. So say you end up at 3, 4, 5 ACH, you probably really should have legitimate mechanical ventilation. And now you don't have budget or provision for it.
Yeah, I think it's pretty good when you bring in the air tightness. Didn't they just do a new study that found that air tightness was better than what they originally thought it was?
Yeah, so CSIRO has commissioned 2 studies over the past 10 years. The one, I think sometime about 10 years ago, found that the average air tightness of a new build residential dwelling in Australia was about 15 ACH. And now in the most recent one, it's down to about 7. So that's great progress for the industry in barely a decade.
And if you're averaging that out over, you know, volume builds, which probably like is a sieve, and then...
But are they? This is the thing. I reckon maybe they're not as much as we think.
Probably not, and that's why the average has come down to 7. But I'm saying like a nice custom build where a builder actually gives a shit, and that becomes your lower end of air tightness, which is bringing that average down as well.
And remember also all of these apartments are going in that are precast concrete. It's very hard not to make those airtight.
Yeah.
Yeah, I think that's the thing. I think we probably think that like residential, like there's residential, but then there's commercial, the commercial side of residential where we're building apartments. I think that's something that when we all talk, we just think standalone home.
At the risk of repeating myself, a comment that I said to Joel on a past episode, the blower door is testing the whole house. Like all your leaks could be coming from one room, and then the rest of your home is completely airtight. So picking an arbitrary number and saying, well, below 6 air changes, you need mechanical ventilation. If all of that's coming out of one room, well, there's a huge amount of risk in that home of having mould and condensation, or even degradation of that building fabric because the wall assembly is getting ruined.
So, Guillermo, there's a couple of suggestions perhaps when we're speaking with clients about how to sort of discuss this that might help. Is firstly to point out that we breathe about 10,000 litres of air a day. So a huge quantity of air. Now, if we think about all of the other things in our lives that we consume water from the taps that we assume, without even thinking about it, is not going to make us sick. Now, there's a whole infrastructure behind that. There's testing of the water quality all the time. And clearly there'd be a scandal. If there was a contaminant in our water system that made us sick, then that'd be first headline on the news. When we go into the supermarket and buy food, we know that there's a whole infrastructure behind that of testing those foods to make sure that they're not going to make us sick. We have no such oversight of our air quality in our buildings, and we spend 85 to 90% of our time in buildings. So air quality is fundamental, and it's a complete oversight in both our building code and our wider community perception, because we just don't see, feel, think about what we breathe most of the time until we get those acute events like the bushfire smoke type of events. Is air quality important to you as a client? Well, yes, of course, everybody would intuitively say so, but I'll just open my windows will be the response. And then I think I would say, well, okay, you're currently living in a house without mechanical ventilation. Under $100, let's buy you a sensor. A CO2 sensor is a good place to start. And let's put that in your bedroom for a week and see where that resides afterwards. And I can almost assure you that in that master bedroom overnight, those CO2 concentrations will go well above the nominal 1,000 parts per million that we always talk about, often well above 2,000. And that's your indicator that what you think is happening, I've got good air quality, might indeed not be the case. Now, to emphasise here that it's not CO2 per se that's the main problem, but it's an indicator of the level of air infiltration and exfiltration in that space. So you can only react to what we can see and feel. Well, we can't see and feel air quality particularly, but we can certainly monitor it with these very cheap tools.
And a lot of that can also explain other things that you might be experiencing physiologically, like I'm always waking up tired.
Headaches,
stuffiness, that kind of stuff. Yeah.
So 2 things here. A recent study estimated that poorly controlled asthma costs the healthcare system $4,600 per person per year. And then in 20 to 21, it was an estimated 581.7 million was spent on the treatment of asthma in Australia, which represented 0.6 of the total healthcare system expenditure and 90% of all respiratory conditions.
So, I mean, that's talking about one component of a healthy indoor environment. I mean, there's so many things, there's so many benefits of a controlled internal environment.
So what I'm saying is, we like those systems that say that anywhere from 18 to 30 grand to install. Let's just say that.
Yeah.
But that's for a whole house. And if we were to start introducing this into the housing systems, surely there has to be a decrease in the expenditure that's going to be needed from a healthcare perspective.
Well, I mean, if you think about it logically like that, then it should be subsidised.
That would make so much sense.
You're subsidising water tanks, you're subsidising insulation, you're subsidising solar panels, batteries, subsidise HRVs or mechanical ventilation.
Yeah,
and there's
checkmate
to run for Parliament next.
We seem to throw so much money, but rather than we're going to spend it on this, but what if we actually can prevent it? And I think that's half the issues.
But a term is 4 years in the government.
3 years federally.
3 years Sorry, 3 years. There you go. 3 years. That's all they're thinking about. They're not thinking long term like that.
But we also need to acknowledge, I think, that a lot of these chronic conditions, asthma being one example, are multifaceted in their cause. We can't. I don't think it's reasonable to argue that if we put HRV in every single dwelling in Australia, we've solved the asthma problem.
But what if it reduces it by 5-10%?
And that's always what we're talking about when we treat these chronic health conditions. This is a multifaceted response.
10%, 85 million a year. That's huge. That's a huge amount of money that we can spend. I just look at it this way: is when I speak to clients, do you want mold in your house? No. Do you like clean air? Yeah. Do you want to filter out all the nasties? Yeah, we want to filter them all out. Okay, do you like moisture and just humidity and all that feeling inside? No. Okay, but you want to cut out the mechanical ventilation? Oh no, we'll have that in now.
85 million is only 4,250 units, HRVs in a home. If we put a Xanadu 350 in. Pardon the problem.
But also,
subsidise the whole. No, you're right.
But you could subsidise the unit and the installation is the same. And as long as they're commissioned with the report on the provision that you also achieve a good air tightness test, you get a subsidy, and then you incentivise also banks.
Well, you're also incentivizing more competition in the market because more people will see an opportunity. And I think that's the biggest problem in this space right now, is that there's no incentive for the broader industry to adopt this stuff because they're not going to make money out of it.
But also, you even look private health insurance, hey, you have one of these, we're going to reduce it. Some of them have, if you join the gym, we're going to reduce your private health insurance. Hey, we're going to reduce your private health insurance as well if you have one of these new homes. And I think that's the only way we're going to start seeing widespread adoption, because we're in a society at the moment is the first question isn't what does it do it? What does it cost? That's the first question we get with anything. What's the cost? What's the extra cost? Oh, it's building so expensive. We're going to add more and more and more.
And remember also there's this immediate comfort benefit to an occupant of walking into a home with nice fresh air. You feel it.
Straight away.
You smell it.
Yeah.
If you go away for holidays for a month and then come back and you're used to walking in sort of a stale space, well, that won't happen if you have HRV. You're sitting in the living room watching TV in the evening. You don't feel the compulsion to open a window because it feels stuffy in here.
Yeah. I think the one thing, though, if you go back to the basic form of mechanical ventilation, I've learned from experience, I can't rely on my clients still to turn on the fan when they have a shower and then they instantly switch it off. So we had a case where there was mold on the ceiling and I was like, hey, what do you do with your fan? They're like, oh no, we never use it. One, that's on you as the client. But two, it still comes back on me because it's well, how do I can't force you to do it. So I would always suggest now is at least have a timer switch. It has to be on some form of a timer switch.
Or you can run them on a humidity sensor.
Yeah. Or some form of it should be at least mandatory that it has to be on something.
And you're talking about a home that doesn't have a central.
I'm talking your basic low air, I shouldn't say low end, but the basic starter pack of a home. Yep. That it should have to be on a humidity sensor or it should have to be on some form of anything because again it's
and it's a few $100. It's $500 to get a basic fan with a humidity sensor.
Yeah.
And vent it.
The insulation,
properly,
installation
not
is all the
just a
same.
space just above the room.
Yeah. Anything else you want to add on that question?
I just
I
say,
forget what the actual question was now.
I just say HRV's got to be the last thing you get rid of. Like, we've got to acknowledge that building a house is super expensive right now. Everybody's trying to find ways of cutting out costs. Please, the HRV is the last thing you get rid of.
Yeah.
All right. This is a bit of a, I reckon this person lived in America, but you don't seem to advocate for the use of external rigid foam insulation. Why not?
So firstly, the material properties. So it's a petrochemical. It's going to last for a squindillion years, which on a building is potentially a good thing. But there are end of life of our buildings. What do we do with these products at the end of life? Now, many of the manufacturers will tell you they're fully recyclable. Well, at least in Australia, find me a recycling facility for these things. Even a lot of the products that we know, we do have recycling streams for in Australia. We have very low recovery rates. So there is a problem inherently, in my view, with the material itself from that point of view. From a building durability or a construction point of view, the issue comes down to vapour permeance. That all foams are far more vapour retardant, or they let less vapour through, than your obvious alternative being your batt insulation like a glass wool product. And so the concern then is, depending on how you choose to do it, whether you are actually introducing a moisture problem into your building. Now, that's not to say that you can design that out. You absolutely can. You can build a foam-built building and it will perform excellently, your classic Esky type construction. But the main thing to me comes back to that materiality, the petrochemical base.
So how about something like waffle pods? Because I've always considered, I know that's not.
It's a clever idea for external insulation.
No.
It's not even insulation.
It depends where you put it. So if you put it under your slab, it goes back to where I'm getting the rigid insulation. I don't like waffle pods at all. I think I've had issues with them recently, trying to dispose of them.
So you're saying that the waffle doesn't have a oven?
It provides some thermal resistance, but I suggest we overplay it. What's the main role of a waffle? It's a void former. It's trying to create a space to reduce the amount of concrete we use and therefore drive down the cost of building that slab.
Yeah.
That's why we invented it. And then we thought,
when you say it like that, actually doesn't sound like a bad thing.
it's not a bad thing.
Yeah.
I've got no problem with that idea of reducing concrete use, coming back to our material.
But now we're introducing it with EPS, so is it any better?
Well, exactly. And you're creating this composite material. If you think of end-of-life recyclability, we have the same in our recycling streams. We have, in Australia, as we know, commingled recycling. We chuck our glass in with our plastics, with our cardboard now, and then someone somewhere has to separate those waste streams out, which is very difficult and costly to do. Here we're creating this monster sort of Frankenstein material that's a mix of EPS, foam and concrete.
I'm going to throw something to all of you here. When we're doing a uncoupled slab, we're putting the XBS on the underside of our vapor barrier, with the hope, thought, whatever, that if they ever did go to recycle that slab, that it's separated. Do you think that's
That's just a good question, because I'm about to do my first that style of...
Yeah, always XBS, and then
Because I had the issue recently last year is we were demolishing a home, and there was, I think, from my understanding, the EPA have changed the rules around disposal of EPS. And because it was in the concrete, it's now hazardous waste and everything goes by weight, and concrete's heavy. So now they can't recycle the concrete, so then you pay a fortune. So it's a really good point, and something that I'm like, I've got to note that down to tell my team.
yeah, plastic on the over the XBS.
Yeah.
I mean, if
Are you not you're not taping the XPS either?
No,
No.
not taping the XPS. No, we're just putting so XPS goes down, and then plastic, and then steel, concrete on top of that.
Shouldn't be any issues from a structural buildability.
Zero.
No, yeah.
In my opinion, zero. But like when they're going to cut it and then jack it up, is some of that getting mixed?
And just another sort of counterpoint to consider, as we've discussed previously, all insulation works on the basis of still air gaps.
Yes.
And that's the same for XPS, EPS as it is for glass wool and other products. And so if you've got that XPS sitting below the water table under the slab and it gets moisture into it and you get water in those air gaps instead of air, water is far more thermally conductive than air.
Ooh.
And so potentially you're degrading the performance of the insulation.
Yes.
Now, XPS is far more water resistant than, say, EPS and certainly glass wool, but it is not, you dunk XPS in a bucket of water and leave it there for a month, it's going to have some moisture.
Yeah, and I think we've actually asked you this question before during, when we've gone to build this, but like in my mind, I don't know, and you can answer this, depending on the thickness, you kind of over-exaggerate the drop in performance. Because I think we were talking about maybe it was even Ramsden Street, I can't remember. But we were talking about putting the XPS on the underside of it and then the plastic. And then I think you said, well, if that gets moisture in a certain level in that XPS, we can only then put into the PHPP that it's 70 mil XPS or 80 mil XPS or something like that. So being conservative about it.
The problem is you don't quite know what ratio to assume for a particular site. What's the water?
So then to completely eliminate that, 2 layers of plastic, and we've got more plastic. We've got more plastic.
But if this is the worst part about our building, to me it's like that's okay. 2, do you sometimes take the boomer approach and surely in 100 years when they're going to remove that slab, which the way we build slabs now should never really move and should always be able to be reused. Is it just going to be like they'll have a system to recycle it?
Potentially. I don't think that's ethical. I don't think we should pass on a problem to our children and grandchildren and say, you guys fix it.
No, we've had enough of kicking the can.
We've done enough of that. It hasn't worked for you, right?
And this one blows me away why we don't have products like Glavel here.
It's so expensive.
In the US, they have Daniel Glauser, who works for Matt Risinger, did a really good post a few years ago, and he reshared it where they had a highly reactive site and they used a cardboard type product instead of a waffle pod that's designed to just deteriorate and go
a void former.
Yeah, a void former.
They use is it Cuplex? Is that the plastic now?
Recycled plastic, yeah.
Yeah, so we have a few other options of void formers. Again, we're just trying to create an air cavity that are plastic based now. Okay, it's not a great material. You could argue it's an end of life thing, but we've got to stop, I would suggest, talking about these things as recycling. Like you're not taking those old PET plastic Coke bottles and making them into couple X by X, whatever, and whacking them in your slab and saying that's recycling. Recycling is reusing for exactly the same or better purpose. We're downcycling. We're taking a material, using it for a good purpose, plastic bottle, then we're using it for a void former in a slab, and that's it. After that, there's,
Could you say it's a better purpose because we shouldn't be just using plastic bottles? So it is upcycling to something that should be, if constructed, there forever.
Well, yeah, but find a building that's there forever.
So can I just touch on this downcycling thing for a second? I mean, okay, upcycling sounds better. Downcycling doesn't sound as good. But is downcycling better than just throwing it out?
We could argue that, but of course we've got to try and get to that fully circular economy where we're recycling for like.
And then I guess you also need to look at what is the embodied carbon in turning it from this product into that product, and at what point is there a tipping point?
And even if you can recycle it back to an equivalent same product, if that's going to require a huge amount of energy to clean it, melt it down, refabricate it back in, then obviously you've got that impact as well.
What a tangent.
I know. So did we get an answer if you use external ridge foam insulation?
What was the question?
You don't seem to advocate for the use of external rigid foam insulation?
No, here's a question. Zipper. We don't have it here, but I thought Zipper was a foam product. Is that not vapor
closed?
Vapor closed?
Yeah, that's right. It is, but it's on the exterior of your construction.
Yeah. Okay. Yeah.
And it really is, from a builder's perspective, a great product. Like, we don't have it here or anything similar. Like, it's, 1, maybe 2 trips around the building compared to the 4, 5 we might take. And you're externally insulating in the same top process. So yeah, it would make a whole lot of sense.
Is it all their insulation though? They're doing that, and then they're doing
And remember also, just when you think about using foam as insulation in our buildings, all three of you probably have done SIPs before, and all of our SIPs panels are OSB faces with a foam core.
Yeah.
So yes, you can absolutely do it, but as a client, you probably just need to comfort yourself that you're accepting that this is a petrochemical of dubious recyclability.
Does water travel, which kind of feeds into what we were talking about a little bit before, does water travel down under the slab insulation and end up under the slab?
Well, isn't that very dependent on your site conditions and how you've managed?
According to some people, water doesn't get past your eaves and go under a house. Matt knows what I'm talking about.
I was about to say the architect's name.
I've got a mate who lives in rural New South Wales on a waffle pod slab, and they've had so much heaving from the ground conditions that in the middle of his house, you can slide your entire arm under the internal wall frame, because as the outside of the house has heaved and with the trusses tied into the internal walls, it's lifted them, and that's how much it's moved just from the expansion of highly reactive clay.
Whoa. I know.
So this is not on a slab though?
Yeah, slabs.
I know like some of our slabs, I've looked at soil test results recently, and they can expect up to 60 to 70 mil of movement within the soil at any time. And I've actually experienced it at one of our houses. What we did is we lasered our subfloor, perfect, lasered the top of the frame, perfect, lasered our windows, perfect, put it in our floor, and then we're just lasering some joinery. And my team are like, it's 50 mil out somewhere, and it sloped 50 mil. So I called the foundation people that we did the alternative footing, and they were freaking out. And we called the soil engineer. He's like, oh, no, we can expect another 20 mil. This is normal. So and because what was happening is, because we're on bedrock across the whole site, we're only be able to get down to a certain level. So once the water hits that bedrock, it had nowhere to go. It just would slow, and it was 2021. I remember it was really, really wet. And obviously it just saturated the soil, and the ground had just become like a big swimming pool underneath it and built it up. So all the clay was just expanding and pushing it up.
I had an issue with a project from friends of mine, and we finished a house at the end of 2021, and there was ham days of rain over that summer. Like, it was astronomical, and all of a sudden everything started moving, cracks everywhere, and then it hasn't moved since. Everything hasn't moved since. Being the really good builder that I am, I went and fixed everything, but I did say, this is not on me. Everything's been checked. The foundations and everything were correct. I almost guarantee it's from the water, and everything's now settled down.
Water management, I think it should be the first question on any site. They get a site survey. What's our part for water? Like, how are we going to get water just away on site?
And it also then goes to, whenever you're looking at a set of plans and you've got a small slab and there's 36 board piers in it, you're like, you kind of know why now. Like, well, we're a project in Clifton Hill, and there's 38 board piers in there on a slab that's...
We usually have them every 1,200.
8 or 10. It's tiny. It's a tiny slab.
But we've had them... at one of our projects now, we were 9 metres deep with screw piles. That's when we hit bearing capacity. And I'm okay with it, because at the end of the day, it's what needs to happen.
You get that at your side at Muffle. No, what's the we scratch the surface and you're hitting rock.
Yeah, but don't you also with rock, don't you, if you are in rock, don't you have to at least be certain, like, you've got to start grinding out the rock to be a certain depth down? I think still minimum.
Your footings still need to be a certain depth to be able to perform. So
yeah, but if you're already at the bearing capacity and you look at like American construction, they'll just clear the whole site flat and then form up their footings on top and then adequately create drainage around, whereas we dig in and hope that nothing's going to fall in that hole. And
what was the question again? Because I think this is probably right.
But also with that, I'm pretty sure with America as well, they don't usually have gutters and downpipes, do they?
It depends on the area, but you should see how well they manage where that water goes. It's not like, they don't have a gutter and it just falls onto the footing. It's like they actually
grade everything.
A lot of planning. Obviously there's, poorly executed things like everywhere in the world, but where they don't have gutters and stuff. Obviously, if you've got gutters in areas where you get a huge amount of snowfall, your gutter's only going to last so long before it falls off the side of the house. So you might as well just not have a gutter.
That's a fair point.
Yeah.
And then just manage where that water goes once it hits the ground.
Yeah, talking to Jonty from Treasure Builders, they're building a place up in Dinner Plain at the moment, and I was having a chat with him over the weekend. Well, there's no gutters or anything up there because it just fills up with water and freezes, and they just all fall off.
Yeah.
But they're managing it through just drainage.
Should every job then have a civil plan attached that is actually designed and signed off? Do you think that should be in order?
Well, let's have a think about it. What kills buildings?
Water.
Okay, well, there's your answer.
It's to cost more.
Well, it's also going to cost
But
us.
Yeah, we always talk about how much it's going to cost at construction, but how much does it cost to then rectify it in 2, 3, 4, 5 years? You know, it's like, Mark's now just put out a thing the other day, which was awesome. Like, you know, we build houses that your grandparents will fight over, not fix, or your grandchildren will fight over.
You know what? Let's also just take a moment and just acknowledge how good Mark's marketing is at the moment.
Yeah,
It's awesome.
It's serious photos.
It's really good. Very serious photos.
This is a pretty interesting one, actually. So when you get into passive house construction, what are the biggest mistakes you can make?
Not ventilate properly.
Yeah, but if you're building a passive house, you have to ventilate correctly.
Sequencing, I reckon, is probably one of the biggest.
Cam, can you talk about sequencing and airtightness?
Well, I'm not a builder. I think Brad's better off talking about sequencing.
Yeah, I think that. Yeah, that's probably one of the biggest mistakes you could make is not understanding when things need to occur or making proper provisions for things, not understanding how certain systems work. You know, if you've never put in a HRV, you might not realise that it needs to have a drain point. You know, those sorts of things, or like, you know, ask Drew how many builds he goes to where a builder's never done it before and, you know, he gets a call up saying, "Oh, I'm ready for the HRV," and they're so far down the line and he hasn't roughed anything in.
Yeah, I'd say yeah. See, there's two things that I quickly come to mind. Is one, a condensation drain for your HRV, but going before that this is one for architects, is designing enough space for your HRV ducts, so having 140 mil drop down.
Minimum.
Minimum. I know that you actually have to. You've got heights, and you're trying to fit in as much, and I respect it. But if you just go, if I allow 140 mil across the whole house, we're most likely safe.
150.
Yeah, we can.
I'd say 150 with your bends.
Yeah.
Yeah.
Especially where the ducting goes into the manifold and then into the unit.
Yeah. And have a dedicated space for your mechanical ventilation. Don't just try whacking in the cupboard under the stairs. Think about, well, then how are the pipes going to get there? How are we going to get that outside? So I think it's also sitting down with, and if it's your first, my biggest suggestion is find someone to fight. Be a bit of a mentor maybe and be like, hey, what did you make mistakes? Like, what did you do? What can you do here? Is this the right location? Or trust someone like Cam and Joel to tell you that, like, no, we can't put that there.
Yeah. I actually took a client and another builder to Hamish's job so they could see how the HRV ductwork rolls into the unit because they had allowed 90 mil and I was like,
no, the duct's 90 mil.
No, I thought the duct's 90 mil. I'm like, okay, tell it to stay in 90 mil.
And also, you've got to go under a top plate at some points, and there's 45 you've already lost.
Yeah, and it's not one duct that comes into the unit. On their particular build, it's 14. 7 supplies and 7 extracts. Like
7 extracts?
Oh, sorry, whatever.
That's a lot of extra.
And remember, you've got the manifolds here, you've got a whole lot of stuff going on.
You've got your
So you need to
HEPA filters.
Potentially. You've got to deal with that. And then just back on the sequencing thing, at the framing stage, remember those starter strips?
Yeah.
You know, that's, how many times have we had to rework jobs where you pull out end plates to get those starter strips?
So it probably comes back, I know you've said with your house, you originally didn't get it airtight in your first house. But I'd say from our perspective, is like we got to learn from what he made a mistake.
Can I just land on that for a second? Cam got his house airtight.
Yeah,
1.2 ways, yeah.
Cam's sorry, it is airtight.
It is airtight.
Just didn't fit the arbitrary numbers of the passive house
yes, thank you for
association.
Thank you for pulling me up on that. But your detailing and we needed that there, we needed that there. So you put that information out. So then people like go, oh, to my team, we need that there, we need that there, because Cam missed the arbitrary number. So we have to get it sort of thing. I think
So we're the sum of every time we fucked up, and I would almost say now, there's a lot of things that we've learnt from all the things that we fucked up on, which now we're not making those mistakes again.
I think the biggest one as a builder, the biggest mistake you can make as a builder is not setting your progress payments correctly for a passive house. It is the number one thing that will hurt you on a project.
Can I just say, one of my current projects right now, and I think I talked to you about this year, 3 months I went without a progress claim because we got some sequencing out in our programming and it didn't quite match up with where our progress claims were. We then realised that we needed to actually build it in a certain way. So we actually stopped doing what we were going to do to get that particular progress claim. And I went down to the line with money in my bank account for not having that dialed in.
So I'm in the same position now.
Yeah.
What I've done in the past, and I've had that issue, is I just told the clients and asked to do a variation
We did
to the progress payments, which you can.
Yeah, we did. So we did that.
Yeah.
We did do that, but it still meant the next progress claim was still a ways out because we needed to balance the quantity of work involved in this and the quantity of work involved in that and make them kind of equitable so the bank would say yes.
And I'd say it becomes way more complex on a double story. That is where I have been caught out.
That's where I got cut out.
And it is the fact that your scaffolding can be up for a long time because if you've got external lining, you need to then seal the penetrations. You can do your battens, but you can't put on the cladding because the roughing needs to be done after the roof and the weather tightness, but blower door test because you've got insulation. So you start to play around with these things.
If this is something we're talking about, I guess just outside of just a passive house, your scaffolding allow much more than you think.
It's 26, 30 weeks minimum.
And then you've got to make sure that all your trades are allowing to make many more visits than what they would normally make.
Yep.
It's not come and roughing the electrical in one hit, come and roughing all the plumbing in one hit.
External panos.
Yeah, once you wrap your roof, before you put your roof sheets on, your roof cladding, you need to get your solar penetration. So there's the solar team coming out for a quick little thing. You've got your stink pipe from your plumber, and now you've also got your electrician usually running the antenna through minimum. And that, so you've already got to seal those penetrations. And the other ones I always do is the window manufacturer and deposit, because you got to upfront them very early. If you have a pre-construction method like a SIPS or a CLT, you need to fund that really early in the project because you might be waiting 20 weeks to get them on site.
And it's not just the deposit, it's all the other progress claims that come along with that.
Yeah, it's not that we're trying to, as builders, I would say here, get money in our bank because we've got to spend it pretty quickly. It's just to keep the project moving.
Get money in our bank so then we can pay.
How about from your side, when you do film modelling, what are the biggest mistakes you can make for someone that might be in the back end before we even get it on site?
Probably substitution. If you are on site, I was going to say product substitution.
Who would do that?
Someone changes something somewhere during construction. It happens all the time, whether it's coming from the client or the builder or architect.
I did it on my own house this week.
You've done it on your own house and it's a pain from my point of view. But, the key thing is, particularly for a project that is seeking passive house certification, always run it by your passive house consultants before we do it. Now, it might well be fine, and in many cases it is, but you need to loop in your passive house consultant because there is a serious risk that you will jeopardise the likelihood of certification at the end of your project. And clearly, if that's in your contract with your client, that could be a real problem.
So that is another thing that I was going to say. Do not put in your contract that you will deliver a certified passive house.
Yeah, so Sven's got a story about that. Because the building surveyor actually took that to the next thing and would not give the final C of O until there was a certified building.
Yeah, and they couldn't release it.
And they couldn't release the C of O. So just on what you were saying before, Cam, in the middle of COVID, one of my earliest sort of ventures into a full-on certified building, prices are going up left, right and centre. We're trying to, manage the budget, and we've got COVID that we're dealing with, building a passive house for some good friends of mine. Collectively, we made the decision to change windows because I had ones coming from China, item from China. We weren't sure how long they were going to take to get to Australia. the modelling went in on these particular windows, which performed better than the ones that we decided to go with. Now, luckily, we didn't have in our contract that there was going to be a certified passive house. We've got a certified drilled-in there, but it's a PHI low energy home because the windows are what tripped it over the edge.
So I think it's also
Not as well performing.
But also on the flip side, as a builder, like if I write, we will give you a certified passive house, I've got to assume that Cam's got all his modelling right. Because what if he's got it wrong and I've written, we will give you one, or we're going to give you one. That's just like, what if all of a sudden he's allowed R4 and we needed to get an R5 insulation on the walls. So now I'm screwed. I've done all my bit. So what I would suggest is, as the builder, is like, if you, as a client, and you want a certified passive house, say that you, the builder in the contract, will reach 0.6. That's a very easy one for the builder to take control of.
Is it though?
I think getting airtight is. If it's a new house, it's so easy.
Materials, because me and Hamish have both done hempcrete houses, and the one that I did very well could have been a certified passive house. What let us down was the airtightness. And what let the airtightness down was the fact that we had no internal render.
But that's on the design, and that should be picked up earlier. But also, were your windows good?
Yeah, but nobody knew. No one can tell you, a 300mm hempcrete wall is going to achieve. Obviously, we know.
I'm pretty sure I said something as you were building.
Yeah, we know. Yeah, we know. You know, in Tello, okay, that's a proven system.
It's a good point. Yeah, okay.
When you're doing stuff with different things, there's no guarantee that you're actually going to get there, regardless of how hard you try. Like I tried really hard and we got to 0.82.
The quotes that our tender documentation, which we're appending to our contracts, clearly state that the project is targeting passive house certification, not saying that we're building a passive house.
But I think even setting aside the legal part of it, we're all diligent, trying our very best for our clients, and we want to, if we say we're going to want to try and make this a passive house, that's genuinely what we're trying to do. We don't want to let down our clients. Yeah. And so as a passive house consultant, coming back to Matt's point, it is absolutely correct that there are 1,000 different places you can muck up this from a modelling point of view, and I do that all the time. And that's why the certification process, for me, offers a great deal of value and confidence, because by getting that independent QA, I've reduced the likelihood that any errors I've made are so significant as to jeopardise certification.
Yep.
So it's providing me with confidence, because we all know we make mistakes, and we've picked up those errors early, and this all should be done pre-construction. Before you get to site, get that first review done, always. And I plead with all the passive house consultants out there to get that done, and or the whole project team, put that onus on, get the certifier engaged, and get them to do that first review.
I think the other thing is a mistake. If you're an architect or building designer and not involved in the builder in early, that's I think personally you're playing with fire.
Yeah, we know that.
Yeah, I know, but how much can we say it though?
Oh, I think we could say it probably on every episode that we put out, but I think people are still going to, I'm going to say architects will be architects, and they'll want to go to tender, and they'll want to.
But I think the issue is let architects be architects. That's what they're really good at. Let us as builders tell you how to build that design. So there you can potentially get more freedom with your architectural design if you allow us to have the input about what if we build it this way, worrying about these things. 100%. So you can push the boundary that little bit more.
100%.
Because at the end of the day, if you were to do a competitive tender as a passive architect and it didn't work, bang, variation. And imagine the amount of variations that you could just claim because you didn't put insulation on your drawings there. It's not there. It's a thermal bridge. We need to insulate it. And you would just rack up variation after variation after variation.
No, I don't disagree with you, but I think a lot of that stuff you get washed out if you've got a good designer and then a certifier involved.
And I've never had that issue, by the way. I'm just talking in hypotheticals.
But it becomes a false sort of, we go to tender and we don't involve the builder till late on the basis that we assume we can get a lower cost for our client by maintaining that competitive tension. But it tends to blow up in ultimately the client's faces, because they're the ones that are going to have to cop the extra cost of whatever needs to be changed.
Yeah.
And I look at it too as well. I think it's also very important to get an experienced team on early. And it's hard because now I'm sort of trying to push potential people who want to get into this side of the industry away. Because if I was a client wanting to building a passive house, I would want someone that's done it before and have the runs on the board. It's like you go to a knee surgeon. Do you go to the knee surgeon that hasn't done one before?
But then there's also the flip side of that argument saying that everyone's going to get their starts.
No. This is it's such. I know this is that was my follow up.
Yeah.
And that's the hard conversation. Like, it is still new. It needs to come back to an education system. Like, we have this passive house certified tradesperson course. I think that should not be there, and this stuff should be taught over the whole apprenticeship. And so by the time of the apprenticeship, you actually have that within your apprenticeship.
It's part of it.
So it's part of it. Having to have an extra course is just making it like, oh, it's scary. And the percentage of people that actually enroll, like, there's thousands and thousands of tradies spat out a year. It's probably maybe 100 that finish that course. So it's such a tiny percentage.
For someone to learn to become a certified passive house tradesperson by just sitting in front of a computer and answering questions is ridiculous.
And you should, until you have maybe
ridiculous. It is a good way to get a base knowledge.
True, but the outcome, I think, is wrong.
Yeah, you should have to have
a project. You shouldn't, yes, do the course, but the outcome shouldn't be that you're a certified tradesperson. You should do the course and say you've done the course, but there shouldn't be a certification at the end of it saying that you're certified until you've done X, Y, and Z off the back of that.
Okay, so do they do the same with the certified passive house designer?
100%.
How about like a lawyer that hasn't done anything in court, or a doctor that's never done surgery, or...
In a lot of those professions, they also have a sort of a mentor system, don't you? You know, as a trainee doctor, you'll go into a hospital and you'll shadow a surgeon around, or a doctor.
Yeah. I know, I actually 100% agree with you, but then...
Do the training and then go, and then the certification part of it is, so you've got your degree, and then you go and get your master's.
Or like when you go for your builder's license, at the moment, you have to show your 3 projects and that you've done that shows experience. So like Mark or Rory or Dave that works for us, they've done it. They've got the experience on site. Yeah, you know what? They can go get ticked off because they can adequately show that they have done it.
Yeah.
And I think the system should be the same. If you haven't done one, well, yeah, how can you kind of be, oh, I'm an expert and I see it all the time, and shits me out the wall that, oh, we're a passive house expert, when you haven't even fucking walked in a passive house.
Pretty sure my Instagram says I'm a passive house expert.
Yeah, but you built them. But there's people out there who be like, and I get it all the time when we go up for jobs against jobs, is like, oh, yeah, they're passive house tradesperson. Like, how many have they done? None.
I only did the course because I had clients asking, are you a certified passive house tradesperson? And I hadn't built a certified passive house at the time, but I'd worked on many and had got a couple to...
But I think you can do that. I think you can, I think you can do the course and you can get the experience. I don't think you have to have built a passive house.
So here's a question. Are you still a passive house certified tradesperson? Because I think, one, you have to renew with, is it International Passive House Association, and log what you've done to keep your CPD points up. I don't think I actually am one anymore, technically.
I mean, maybe I'm not, but
like, this is the other thing.
I think that just kicks in again when you get a certified building.
Yeah, but the thing is, like, these people who are doing their passive house course 5 years ago haven't built one. You're no longer a certified tradesperson. Like, that's which is stupid because you've done the studies.
Yeah,
and I'd say the studies that when we did a lot better.
You don't forget stuff too, though. Like, you know, if stuff that I've learned in front of a computer 5 years ago, I'm going to forget.
And things change.
Unless I'm not actually doing it or actively going out and, as you say, getting the CPD points or going to events or whatever, or listening to these podcasts.
Yeah. But I think as a client, you probably don't want an inexperienced builder building a certified passive house as their first thing. But the way that the industry is now, especially in Melbourne, Victoria, it's a lot easier to get some runs on the board as a tradesperson because now there's more builders doing it. And if you reached out to any of those builders and said, hey, I'm really keen to be involved on a passive house project to learn, is there some capacity that I could jump on board and get some real life on-site experience? I don't think there'd be many that would knock you back.
I literally had a message yesterday for exactly that. We're a chippy crew looking to expand. Our builders love what you do, really interested in working on some high performance homes. So it's happening now.
But I also say at the same time, this is also drives me insane, is and not picking on this carpenter, but you're framing. You're a carpentry framer. Change the way you frame it. Like, no, that's how we now frame. We frame it at a high performance level. We're doing California corners. This is how we're knogging out. Well, you're just going to force the builder to change.
Yeah.
I think sometimes also people just have to force that change and be like, this is how we frame now. It's better for the building.
Yeah.
Let's leave it there.
Is there another question?
We've run out of time.
Oh.
Yeah.
I'm looking forward to the other question.
Yeah.
Okay. Oh, well, there you go.
Thank you, Cameron.
Did we answer the question?
Half we got there somewhere.
We went off on a few tangents.
So that's the whole idea of it. I think it just creates great conversation. We can actually go back and forth in creating the arguments. So yeah.
Is that it?
Yeah. Thank you.
Okay.
Thanks everyone.
That's it.